While I get my things up, I am just so blown away by the talks right now. I am in the process right now of making a Transformers for computer vision course for LinkedIn Learning. And I'm just trying to fathom how many more courses I would have to make to get to the level of these talks that we've had. We'll not be going as much depth in it. Tons of helpful and insightful things from the last three talks. So I really appreciate it. But with a limited time left, I have a nice fun talk for everyone here today. It's one of my favorite topics. It's one of the first topics I actually got into in computer vision, which is RGBX model development. So we're going to be talking all about four-channel model development, and sometimes it's more than four channels. So to set the stage a little bit here, first, my name's Dan. I'm on the Voxel 51 team here with Jimmy. I do some of the machine learning work as well as the developer relations. I've been working in computer vision for probably 6-7 years at this point, and always had a soft spot for any type of RGB image that also has a little bit more fun packed into that fourth channel. So just a couple other things. The stock market's been dropping. People are still unconvinced about AI, but I don't buy it, right? Everything's still scaling up. People are, adopting more and more things to their stack, building up their codes bases, securing GPUs. There's by no means any concern about this, right? But previously, like the last talks that we had, there's a lot of work being done right now that is work to build towards something greater, right? We're not quite at the level right now where we are fully supporting all of these use cases, right? Where, we don't have fully autonomous cars yet that are driving everywhere. We don't have robots that are interacting with human life all over the place today, right? So some of the work that goes into building these systems, whether it's relational fields or these transformers that we saw before, it's not sexy, right? It's not going to be the most fun stuff, but it's very important, right? So even if you're not building the engine to your car, for instance, it's still important to build the suspension and the wheels and the transmission and the GPS and all that other important stuff. And that's kind of what I hopefully aim to capture today in today's RGBX models talk. So if you're not familiar with what potential option here for the X here is, it can be some of any of these things, right? This is the Sapiens model coming from Meta, which is one of the most popular models right out there. It's specifically for people, but you can see we have normals, depth. You can even classify segmentation or pose almost as one of these type of models, but infrared would fall into the same category here, where the goal of these models is either to input or output to four channels or more, right? We're not just looking at those RGB pixel values, but we're actually looking at additional information that is provided to our model, or looking to predict output information to mimic a sensor that is maybe not available on the system that you're building here. So we have some examples. This is utilized across pretty much every industry. We have examples of some depth here, right? You see the tables and the cars, and you can see, sure enough, the table's a little bit brighter than the rest of the background, and it gets darker as you get further back in the room. We have some surface normals, which helps us understand the curvatures and shapes of things in the scene, understanding how, we can build this out into a 3D representation, as well as some infrared, right? Whether it's low light conditions, you're looking for organic matter, things like that are putting off these heat signals. Infrared can also provide a lot of information into your model's inferencing. But as we kind of go through this talk, we're going to phase it into two separate groups here. I want everyone here to kind of think, why does this work matter, right? Does it matter today? I kind of cheated a little bit on this, but just kind of think about how you can imagine this being incorporated into future works that might not come out in 2025, but might be hitting it in the next couple years or so as well. So let's first start with how these RGBX models are being used today. I've actually had some firsthand experience here with both of these kind of categories. I've worked on some autonomous vehicle workflows and all the different sensor inputs. I actually have a small demo I'll be able to show at the end of this, as well as one of my first real jobs in computer vision was building night vision goggles. That, sometimes, when you wear night vision goggles and there's a lot of light, I go blind. But if I don't wear the night vision goggles, it's too dark and I can't see anything. Can I build a set of goggles that always mimics, exactly what I need to see, right? And this was using UNets at the time and being able to blend the two of real light and infrared. It was a really cool project. One of our first main use cases is tracking, right? This is one of the most common forms of RGBX models. It's an extension of a traditional object detection model, but it's basically, given a normal problem set, I want to track something, whether this is tracking traffic, tracking people, security, surveillance use cases, of course, are very important here. But it can be other things as well when we think about things like in self-driving use cases where RGB is just not enough for me to kind of understand all the context of what I'm looking at. So if I add in those extra channels of modality here to give my model more information, then we're going to be able to have a more accurate tracking algorithm, right? So how does this work? Usually what you do is you take the RGB image, pass that in, take in the extra channels, whether that's infrared, event, or I believe it was depth in this case. Then you're going to be able to do a shallow embedding, prompt it, pass it into the tracker, and then you're going to be able to keep track of these new objects that you found in a multimodality method, right? So now you can pass in any amount into this type of model here. This is using the RGBX tracker, which you can pass in only RGB. You can pass in all three of depth, event, thermal. You can only pass in a couple. And only adding more information is almost always going to help your model do better. Another super common one that is being used today is to help survey difficult terrain, right? Sometimes it can be very hard to access certain places to get a proper look at how they're doing. A classic use for this is things like nuclear reactors, especially like decommissioned nuclear reactors and stuff like that. I want to make sure that there's no cracks, no faults, that everything is doing okay. However, I don't really feel very comfortable dropping like an engineer inside of a nuclear reactor, right? So what we can do is we can build these camera systems that are very robust and such that are able to survive or easily navigate these kind of situations. Subway tunnels is another classic one where I can create a map of the area just by flying through a drone. By leveraging things like depth sensors, as well as potentially infrared or other types of sensors if it's low lighting conditions or hazardous lighting conditions, then I'm going to be able to get a much more clean view of the situation than I would otherwise. Another super easy example is something like skyscrapers. I could just fly a drone up the side of the skyscraper, and all of a sudden I have a 3D look or nice quick scan of that side of the skyscraper that I can check to see if there's any faults or any engineering concerns that I need to address. The nice thing about this is that most often, at least the sensor calibrations and the model inferencing can be happening on board of that drone. The 3D projections and renderings and reconstructions might have to happen offline on a laptop nearby or something like that, but it can be very efficiently executed on the edge, this kind of workflow. So here we can see on our bottom left a use case of just surveying a building, understanding the kind of world that's going on and anything that's going in. But we also have an example on the right where this is commonly used for things like law enforcement and military operations, search and rescue as well, where, I think I have another picture later on that will show this, where, instead of looking at like a map or a 2D picture, I can very quickly fly a drone in, understand the situation, understand any obstacles, maybe where potential threats are, where people that need to be rescued are, much quicker than a human could walking through and scanning this information themselves. However, we are moving to a new frontier, right, where we're leveraging these models not just to input, as we've been kind of looking at the last kind of cases, but also output as well, right, where here we're looking at the SAPIENS model. This comes from Meta, where if you input I believe the correct terms they used is a person ego video, something along those lines, where basically the main focus of the video is a person. Single person can do multiple, but it kind of falls off. Think classic things like social media that you're sharing this potentially on. Then I'm going to be able to automatically generate pose, segmentation, depths, and normals. Now, I love this paper. You should really check it out if you haven't been able to do it before. Because basically, we had been playing in this pose, segmentation, depth, normal arena in computer vision for many years. Meta came in, were the first real enterprise style model to drop in this field of computer vision and just absolutely crush all the state of the arts by like 40% in some areas, right? Not only are they the best segmentation model on humans, but they added new classes. As you can see, it's not just their arm, it's the upper arm and the lower arm and the hand and the teeth and upper teeth and lower lip and upper lip, right? They are getting so much more context available through these segmentations and such that even if you abstracted back to previous state of the arts where it was just arm, hand, head, things like that, they're still crushing it, right? This also works the same way for depth maps, as well as it works for the normals as well. They all are state of the art. They have this really interesting paper about how they go through their pre-training and how even if you scale these models down from the billions of parameters that they are, you scale it down to something more similar to what the previous state of the arts were, which were maybe 500 million at the time, things like that, parameter models, they still beat them, right? Because they had very interesting pre-training methods, how they can incorporate all the different masks and modality types. I can't go into all of it in this talk today, but I highly recommend checking out that paper. But this all kind of leads into the next kind of points, which is how are we going to build these systems of the future? Well, if you want to try out building it yourself, if you haven't ever built a RGBX model previously, feel free to check it out, our demo we have on our website, where you can build your own monocular depth estimation models using the Sun RGBD dataset. We have the whole monocular depth estimation one that we built in conjunction with Hugging Face here. So be sure to check it out. But revisiting that why, in a vacuum, none of these use cases that I've talked that much are really moving the needle for what we hope that next frontier of AI to be, right? We've talked about night vision goggles. We talked about social media, basically filters, right? So my filter is now going to apply better on my face on social media, as well as, surveying abandoned nuclear reactors. These they are very important use cases to some people and to a lot of people, but not the ones that are going to move the needle. So why is this work important, right? So we're going to revisit what we started this talk with, which is it's all about how we can look to the future, right? We need to always be conscious and cognizant of what we're building towards for AI, right? How can we kind of ease the life of people? How can we increase the safety of people around us? How can we make sure that whenever, and it's whenever, right? It's not if, it's when, robots are going to be incorporated more intimately into our daily lives. How can we make sure that those relationships are as best as possible, right? You can imagine very simple use cases that we're seeing today, right? Where we talked about that police use case or that search and rescue use case, where if you are building a agentic workflow, if you're building a embodied workflow, or you're just feeding these AI of the future information in order to make accurate inferences, well, more information is always going to be better than less information, 99 out of 100 times, right? So if I'm feeding these models information, would I rather default back to that satellite imagery that maybe I have from a couple months ago of the area and say, hey, this is all I have, here you go? Or would I rather to quickly fly a drone through that area, be able to scan and reconstruct the area in a 3D way where, we even heard from some of our previous talks here, now we have these models that are much, much better at understanding scenes and things like that, right? So if we're able to build these models today that do this kind of translation, that will only help feed the models of the future that are going to be taking in that information and doing even more complex predictions. Same thing kind of works here where we think about sapiens. Would you rather post in just this image to a model where, maybe this is an agentic model where there's hierarchical use cases, right? There's a lot of models working in comparison. Or would I rather give a model all this information potentially? How far away is someone standing from me? Are they facing me? Based off their facial expressions, are they happy to see me? Are they sad to see me? Right? Are their arms crossed? They seem, standoffish, right? All this kind of stuff where sure, you could abstract all this from the RGB image. Obviously, that's what Sapiens is doing here. But it's probably not the smartest idea in the future to ask one giant model to do all this all the time running concurrently, right? If we can kind of break this up to more individual tasks where models are very strong in specific areas and kind of segment them out to perform their tasks in order to feed that information to that higher up model. I think that is going to be the way that the future of AI kind of develops in this area. So what does this mean? We're going to slowly ramp up here. Number one, it's always going to be better for search, right? Anytime you have more information, it's always going to be better. This search can be things like your classic search engines, but it can also be things like vector databases. It can be finding the most important situations, right? You can imagine a case where you are doing a criminal database or something like that, and you want to know, have you seen this criminal before? I could send in a single mugshot, or I could send in a video of him where I have these depths and key poses, and I understand the distance between his eyebrows and all this kind of stuff, right? Or you can do these searches for other things as well, right? Search is always going to get better when you have more information going into it, and building these RGBX models just provide more channels to search across. The second one, as I've been hinting on, is this embodied AI kind of platform, right? When you're in your self-driving car of the future, you need to know exactly how far away cars are in front of you, right? You think about things like Tesla. They famously don't use LiDAR cameras, right? Well, I can promise you they have some kind of depth estimation built into their cars. Otherwise, they would be running into the back of everyone's car, right? You wouldn't know how far anything else is away from each other. So it's always important to make sure that you have this information, whether it's depth maps, whether it's segmentations, whether it's surface normals, to have more context of the scene around you, to not only transport people safely from one end to the other, but also access more interesting things, right? Based on my conversations that I've had with multiple car manufacturers across the world that are building these kind of systems, it's not crazy to believe that a lot of the interior of the cars will be gesture enabled, right? Where you can point at something outside and say, well, what is that? Or what's going on over there, right? And being able to track that point and where you're pointing and how that relates to everything around you will be very important with how we kind of build these models in the future. And then lastly, I think the most important one is the human to robot interrelationship, right? We want to kind of navigate that uncanny valley as best as we possibly can, right? Where when we're having relationships or we're having conversations, when we're working alongside robots of the future, I want them to react to them stepping too close to me and I look uncomfortable, right? My facial expressions are going to change. My gestures might change. My body language might change. I might take a step back. I might cross my arms. I might make a sad face, right? I want the robot to be able to react with that as the same someone else would react to that instead of continually to make me uncomfortable, right? Because if humans aren't going to be able to be comfortable working alongside of the robots of the future, then we're not going to be able to move very fast in that direction, right? We want to make sure that these things are introduced in the correct way, in the right way, and in the safe way, right? We don't want to build these robots where maybe they're very well at executing their job function, but they're terrible to work with. They're cold, they're emotionless, they don't have any feeling of like human interactions, whether that's body language or things like that, to make sure that they're going to be implemented in the best way possible. So once again, two things I can show you. One is that monocular depth estimation. That's on our 51 website where you can get started with the Sun RGBD dataset. This is depth estimation. But if you want to see how we're working with this today, I can show you this NVIDIA Omniverse dataset where it's AV. This is a synthetic dataset. And the fun thing about synthetic datasets is you can add all this information as much as you want, right? So if you want to know how this is working in 51 today, well, I have some surface normals. We can lay that right over top. We have some depth maps. We can lay that right over top. And whether it's semantic instance segmentations or semantic segmentations, you can upload and view any number of these on your data set, as well as put it right next to the ground truths, whether that ground truth is radar, LiDAR, bounding boxes, view all these kind of surface normals as they are seen on your data set, all in one place. Super, super easy with 51. It's literally just kind of loading it on top of the image. You point me to where those labels live and we can help build it with you. So super excited for that. We're going to have even more to show in that area, but just wanted to show off kind of how those kind of work inside of 51 and happy to kind of discuss. I know we're right at time here, so If you're interested in joining the team, be sure to check out voxel51.com. We are hiring for machine learning positions. We have some research positions open as well if you're interested in joining our ML team, as well as more other positions as well. So be sure to check it out. I will answer any questions that we have in the chat or the Q&A box. I'm going to take a quick look. Thanks, Jimmy, for linking those out for me. Let me get to the Q&A widget. Seems like we have a couple.
Your last question there, which is, what weaknesses have you noticed with the Sapiens model?
Great question, right? And so the weaknesses I've noticed with the Sapiens model is mostly how they have constrained the use case, right? What I mean by that is that Sapiens is a model meant for social media, whether they say it is or whether it's not, like it is, right? It is a model meant for me to hold my phone up like this and take a video of myself, right? And then I will put my cat ears on or whatever it's going to be. And it's really, really good at that. Whenever you turn the camera around and now I point it at something, it's not terrible, but it's not great. And the moment I try to do this across multiple people in the video, then it's going to fall off, right? So that Sapiens, let me go back a couple steps here. That Sapiens demo here is only meant for mostly single people video inferencing, right? Where you're taking a TikTok style video or a, selfie style video. It's really, really good, but it doesn't work on anything else pretty much other than that. Any other questions?
Does look like, yeah, you've got one
Go
from
back to the
Pierre.
job link someone asked. It's just voxel51.com/jobs.
Yeah, you got a question from Pierre, which is, while more information is always helpful, it is often hard to get large multi-channel data sets. For instance, you could have a large RGB data set and even large infrared data sets, but much fewer images where you perfectly match both. How would you deal with this? I'm guessing training separate models and late fusion of their last layers.
Right, Pierre, great question. Great question. So yeah, it is unfortunately the reality that we don't have really great RGBX data sets today. Believe it or not, there are actually really, really good ones. They're actually all in China for the most part, for whatever reason that is, right? And they all live on the Baidu cloud. And so they're kind of difficult for us to get access to here in America. So if you're interested and you're able to, try to check out some of those. There's some really interesting tracking ones. There's some really interesting other RGBX data sets. But yeah, that is the case today. So how would you do that? I think late fusion is a great example. If we go back to my diagram that I showed earlier, you can do the late fusion. You can also kind of try to build this latent space that kind of understands all of the different representations, no matter what the modality is. But it is tricky for sure, right? Ideally, you would just want to have the data set. I think one of the possibilities here is synthetic data generation, right? I think this is a great use case for it, where I can kind of add as many of these sensors as I want without paying upfront for the price of it. Now, I'm not the biggest bullish, most crazy synthetic data set guy, but if there is a huge use case here where given any scene, I can use a synthetic data generator. There's a couple out there today, which will allow me to do infrared and will allow me to do normals and depth and all these kind of things, even though I'm not doing that in real life. As long as you trust your synthetic data generation to be accurate enough, you can begin to generate these kind of data sets that have pairs. Now, should you only train on synthetic data sets? Of course not. You should be able to kind of diversify yourself a little bit. But that is definitely a great way today to kind of close the gap, I believe.